Okay, all right, now our recorder is running, so others who missed can get access to what we have discussed today. Again, I advise those if you can keep your microphone off, you can only turn it on when you have a question to ask, or if I have asked you to make a contribution, so that we don't get unnecessary interference. Okay, just to confirm, are you all hearing me very well?
Yes, sir.
Sharima, you're welcome.
Yes.
You've just joined. Welcome.
Thank you.
Okay, so let me just share my screen and we begin where I wanted us to start. So let me just do a screen share now. Right, I think that's where we are at. Okay, that is one. I need another one to share. First, this one. Okay, so can you all see my screen? Are you all able to see my screen?
Yes, sir.
Okay, so yes,
Yes, sir.
all right, thank you. I wanted to just confirm, and then we begin. So we're looking at equations that have only one logarithm on one side and no logarithms on the other side. Last Tuesday we looked at equations that had logarithms on both sides, and we looked at the method of solving them. So today we are dealing with equations, or solving logarithmic equations containing terms without logs. So that means one side will have logs and then the other side without logarithms. So how do you solve them? So the steps are in the next page. I want us to just go through. These are the 5 steps, like also we had with the equations which had both logarithms on both sides. So the first step, of course, is to just inspect. So let us just go through the steps. You determine if the problem contains only logarithms. If so, then we use the steps for solving logarithmic equations containing only logarithms. But if it is not, in this case we are dealing with not, so we move on to step 2. It is okay. So step 2 is to use the property of logarithms to simplify the problem if needed. That is on one side, the left hand side or the right hand side, depending on where the logarithms are. So we simplify the problem if needed. If the problem has more than one logarithm on either side of the equal, then it can be simplified. Again, this you use the process of what? Either addition or subtraction. We know if it's subtraction, then we are dividing logs. If you are adding the logarithms, it means you're multiplying the numbers. If there is a power, that means you have to multiply on the other side. So we use those rules to simplify the side which has logarithms. Emphasis, it's the side which has logarithms. Okay? Then step number 3, after you've simplified, you rewrite. That's now very important step, the new one. Rewrite the problem in exponent form, because on the right hand side there will be just a number. So how do you rewrite? You take the base and then you raise the base to the number that is on the right hand side. Or if the number is given as a big number, you look at the base and try to factorize or find simplify that big number in terms of the base. You're raising the base to what power? The idea is basically to get the powers. Okay, then step number 4 is to simplify the problem, and then you solve it. Have solved for the unknown. After solving, you check again. There's always for logarithms, it's important to check. Reason that you cannot have a negative logarithm, so it's important to check. So the one which gives you a negative log, you drop it. The solution that gives you a negative logarithm, you drop. Not necessarily that x may be negative. X may be negative, but the logarithm is positive. So the emphasis is on negative logarithm. Okay, that's the rule here. Remember, we cannot take the logarithm of a negative number, so it's important to take note of that. So it's very important that you always get a positive result at the end, that the logarithm of a certain x is equal to positive, not logarithm of x can be negative, but its logarithm should not be the logarithm of the number cannot be negative. So that's important. Right, so those are the rules. Again, check. If it only has one log on one side, that means now for you, you're going to use step number 2 to simplify, and then exponent. The new component here is that you write the right hand side. Either if the right hand side is a small number like a 2, a 3, that means you take the base, raise it to that power, and that will give you your the solution. You simplify it, and then you get x. Or if it's a big number, 128, and you know the base is 2, that means somehow you must factorize to 128, express it as a power of 2. So that is something that we need to do. So those are the rules for solving logarithmic equations that contain only logarithms on one side, and on the other side no logs. Okay, so we're going to look at some examples, numerical examples, to help us in that area, and then I'll give you also some exercises to do. Right, so the example is here. We are going to solve, for example, the question says solve the problem log base 2 of 5x plus 7 is equal to 5. Okay, log base 2 of 5x plus 7 is equal to 5. So you see, logs are on one side, the solution, the logs are on one side, the right hand side is a number. So this is a classic example of an equation that has logarithms on one side and no logs on the other side. So this problem does not need to be simplified because it's already combined. All you need to do in step number 2 is pick the base. I've highlighted the base. So the question says log base 2 of 5x plus 7 is equal to 5. What does it mean from your definition of logarithms? So that takes us to step number 2. Let me just step number 3, rewrite the problem in exponential form. Okay, so rewriting the problem in exponential form means now we are looking at it is already simplified up to this level. It's already simplified. So here, let me highlight that. Highlight. So what does that mean? It means if you raise 2, okay, I'm looking at 2 here. 2 is the base. The meaning of log base 2 of 5x plus 7 is equal to 5. It means if you raise 2, the base, if you raise 2 to power 5, the result is 5x plus 7. That's the meaning. Logarithm base 2 of 5x plus 7 is equal to 5. So it means if you raise the base, which is 2, to power 5, the answer or the result is 5x plus 7. So that is the rewriting, the simplification. And once you do that, then I think we are good to go with the solution of the problem. We're good to go with the solution of the problem. Okay, so here we go. So it means 2 raised to the power 5 is equal to 5x plus 7. And now all you need to do is, we have reduced this now to a linear equation and we solve it. 2 raised to the power 5 is 32, and then 5x plus 7 is 32. Of course there's a line that has been skipped, but you would say 5x is equal to 32 take away 7. 32 take away 7, what is the result? The result is a 25, and then you divide both sides by 5 so that you get your x being equal to 5. Are we all together there so far?
Yes, sir.
Is it all clear?
Yes.
Okay, good. Right, so that is one example. I want now to move to, there are others which we will look at natural logarithms in the next session. Today I don't want to introduce natural logarithms, so we have looked at that example. Let's look at another one. Another example is here. Hold on, my network is misbehaving, but I hope you can all hear me. Are you hearing me?
Yes, sir.
Okay. Right, so next is to solve this again. Another example: solve log base 3 of 9x plus 2 is equal to 4. Right, again it has only logarithms on one side and on the other side non-logarithms, so we all need to do is rewrite. So there's no simplification required here. Shortly I'll get another number that requires simplification. So we get log base 3 of 9x plus 2 is equal to 4. It's equal to 4. Okay, so what does this mean? It means the base, which is 3, if you raise it to power 4, let me highlight the base, raised to power 4, that is the power, okay, the result will be 9x plus 2. 9x plus 2. So again here we are simply reducing a log equation into a linear equation using that concept, and then the rest is for you to just simplify. Okay, so 9x plus 2 is 3 to power 4. 3 to power 4 is an 81, and then you take 2 to the other side, so 9x plus 2 minus 2 is 81 minus 2, that gives us a 79. Divide both sides by 9 and your x value is 79 over 9. Again, always check, so put back your x and you see whether you get the 4. All right, now the next example now involves 2 logarithms on the left hand side. So when you have 2 logarithms on the left hand side, you must use first step number 2. Use the properties of logarithms to simplify the problem on the left hand side first, okay, because it has more than one logarithm on one side, so you have to simplify. Okay, so here we have log base 4 of x plus log base 4 of x minus 12. Okay, so when you're adding logarithms, we apply the rule that, okay, step number 3 here, we apply the rule that adding logarithms means you multiply the numbers, multiplication. So we will simplify this as, so the numbers you're multiplying are x and then x minus 12, x and x minus 12. Those are the numbers we multiply. All right, so we simplify it, so we get log base 4 of x into x minus 12. So product, multiply the numbers, the result is 3. So once you have you simplified it, the idea is to write the long logarithmic equation to reduce it to just one log, so that you can now apply the principal exponents, the definition of logarithm. So apply the definition of logarithm, that will give you, you see, the simplification will then come once you apply the rules of logarithms there. Okay, so okay, here we are. Sorry, I needed to check something. It's now checked out. Okay, so we have x into x minus 12 is equal to 3. Once we have reduced it to just a single logarithm, then we apply the rule or the definition of log, that this means if you raise 4, which is our base, if you raise to power 3, raise 4 to power 3, the result must be x into x minus 12. That's the definition. So once we have gotten that right, then we just write it, simplify this equation, and see what type of equation we get. From here we see that we have x into x minus 12 is equal to 4 raised to power 3. Now 4 raised to power 3 is 64. That is 4 times 4 times 4. Just there use your calculator to get the value. 4 times 4 times 4. Okay, so expand, so you get x squared minus 12x is equal to 64, and now already we see it is x squared. That means it's a quadratic equation, and for quadratic equations one side must be equal to 0, so we subtract 64, so we get now our quadratic equation as x squared, there we go, x squared minus 12x minus 64 is equal to 0. Then we come use the property of expansion, and you factorize this, not expansion, factorize. And when you're factorizing, we are factorizing 64, that when you get two numbers such that when you multiply them you get negative 64 as the product, and the sum must be negative 12. That means the two numbers must be, one must be positive, one must be negative, with the negative one being bigger. So when you do the factorization, the two factors are 4 and 16, with 16 being negative. Chigundu wanted this step, so this is the step. Once you know the factors, you just come straight away here and write them as it is. The positive number is a 4, the negative is 16, so you write the two products now, the two equations, x plus 4 times x minus 16. Yeah, so that's where we are, and we simplify that and get okay, and end up with the x values being either x is equal to negative 4 or x is equal to 16. Right.
Sir, now what is others? I'm not seeing other steps, sir.
Which other steps, Joanne? I was trying to check whether somebody has joined. No one has joined yet. Let's come back here. Which other steps, Joanne? We are here. So this is our equation. The idea here is that
I think John is meaning the other one of saying either this or this, those things.
Okay. Right. The assumption. Okay. Here I have taken the assumption that you now already know what we do, because the zero property is applied here. Yeah, at this point, if you have x plus 4 into x minus 4 is 0, either x plus 4 is 0, where you get x being equal to negative 4, or x minus 16 is equal to 0, where your x is 16. Okay, so I skipped that step, just understanding that now you are almost familiar with the process. So that is where we are. Okay, so check again, you do a check. So with negative 4 and 16, if you plug in negative 4, it is already direct here. If you put in negative 4, in the original equation, you get log base 4 of negative 4. This already eliminates negative 4 at this point, so you cannot use negative 4. So our solution will be the positive one, which is x16, because you can't have log negative 4 of a negative number. So negative 4 is eliminated right at this point if you try to plug it in. Okay, so now over to you. I'm giving you more numbers. Okay, maybe let's do the subtraction one. No, this one, the drop logs, this one we already did. This is the previous example. So I'm going to, I want the subtraction. I'm going to get an exercise that has subtraction. Yeah, this one, example 5. Okay, example 5, I would like you to follow with me. Example 5. So example 5 says solve log base 2 of x plus 1 minus log base 2 of x minus 4 is equal to 3. Again, as you can see on the right hand side is a number 3, so that means you solve it with the idea of exponential in your mind, the definition of logarithms. This is logarithms on the left hand side. On the right hand side there are no logs. Okay, so in that case we come to step 2. So here you are subtracting logs. Apply the principle of the rules that we have. When you're subtracting logs, it means you're dividing the numbers. So which numbers are you dividing? You are dividing x plus 1 and x minus 4. X plus 1 and x minus 4. You are dividing those ones. X plus 1 and x minus 4. So you combine. So this log base 2 of x plus 1 minus log base 2 of x minus 4 means it's log base 2 of x plus 4 over x minus 4. So once you have reduced it to now a single log on one side, then you use the definition of logarithms. This means if you pick the power, the base is 2, the base is 2, I'm going to highlight the base is 2, you're raising it to power 3. Okay, so base 2, so it means 2 raised to power 3. The result is x plus 1 over x minus 4. That's the meaning. Okay, so all we need to do now is basically see whether this is a linear equation or not. So we write it as, now 2 to power 3 is an 8 already, so x plus 4 over x minus 4, so x plus 1 over x minus 4 is equal to 8. And then what do? We cross multiply. If you write 8 over 1, so it's x plus 1 over 1 times 1 is equal to x minus 8 times 8. Cross multiplication. 8 is 8 over 1, so x plus 1 is multiplied by 1, which gives us x plus 1. Then you have 8 into x minus 4. Then basically this is now just a linear equation. and you solve it as a linear equation. So collect terms with x on one side, terms without x on the other side. So bring this x to the side of 8, so you'll have 8x minus x. Bring 32 to this side with addition, so 32 plus 1, which becomes 33. Then you divide both sides by 7 to give us x being 33 divided by 7. So once you have done that, check it again. It's so that the solution should be the same. Okay, so those are from my side. Now I'm going to give you exercises which have such problems. Here we have them here. Okay, so I'm going to give you, let me see with the ones I want you to do. Right, so I would like you to do, right, we have problem number 4. Are you all with me?
Yes.
Are you with me? Problem number 4. Okay, so I would like each one to do that right now and you tell me the answer. So do number 4. Let's do number 4. Yes, and number, let me see. Number 4 and number 2. So we have number 2. Do number 2. We highlight them. Problem 2 and problem 4. Let's just do those right now before I bring more exercises. So do those now. Let me see. You tell me when you're finished. 2 and 4. 2 and 4.
Me, I'm sorry, I may not do it because I'm in darkness, even I'm serious on this thing.
Okay, you are excused. Harinda, you're excused. The others, Joel, Sharima, Joan, you're not on duty, so yes, do them now. And tell me. Okay, who has finished? Anybody who has finished? Apart from Arinda, I have Joanne, Shamira, or Sharima, sorry. Yes, let me get answers. Joel, you're on hold. What's
We're
up?
still trying.
Joel, are you with me or you are out?
Sir, for me, number 2, I've got x is equal to 37 over 63.
37 over 63, that is correct. Very true. Yes. Who is doing number 4? Number 4. Number 4. All right, can I get us an answer for number 2 now? Number 4, sorry, number 4. Number 4, who is there?
We are still looking for factors. We are looking for factors.
The factors are very clear.
Just help us and you give us factors.
Hey,
Now there is a problem in
what?
factors.
Factorizing 36? 36. Are we factorizing 36? Are you all with me? Are we doing the same number or we are doing different numbers?
Okay.
Aren't we factorizing 36?
We are doing number 4.
What are we
Negative 36 and
factorizing?
negative 9.
Yes, so product is negative 36, the sum is negative 9. That means one of them should be positive, but the negative one is bigger, right? So 36, when you factor, is 1 and 36. It is 2 and what? 2 and 18. 3 and what? 12. 4 and 9. So one of those factors surely should have a sum of negative 9. So which is it now? That should be easier. Anybody who has seen the factors now? The one you use?
Yes.
Tell me. Sorry?
We are using 2 negative 18.
It cannot be 2 negative 18 because that one can't give you a sum of negative 9. Product should be negative 36. The sum should be negative 9. So it cannot be 2 and 18 definitely. What are the other factors? Hello. I'm waiting.
So maybe 12 and 3.
Yes, it is
Yes,
12 and 3.
12 and 3, negative 12 and positive 3.
Yes, when you add them, you get negative 9.
When you add them, yes, you get 9. When you multiply them, you get 36.
Yep, that's it. Those are the two factors.
Okay.
Those are the two factors, and when you solve, basically your solution is x is equal to negative 3 or x is equal to 12, and we will check. When you check, you should be able to say x is 12 is your right solution. Okay, so
Yes.
you need to get used to these factors. They are very interesting, and it's when you get used to them, they're actually a lot easier to deal with. Okay, so let's conclude with number 6. Number 6 is in the same realm. Number 6 here. So do number 6 again. I want you to do number 6 just to be sure that you are very comfortable with the rules. Number 6. Number 6, log base 4 of 3x minus 2 minus log base 4 of 4x plus 1 should give us 2. Okay.
So for me, I'm not seeing the logo very well.
Sorry? It's base 4. Log
I'm
base
not
4.
seeing the log.
4. It is a 4.
Pardon?
It is 4. Log base 4 of 3.
Yes, there I'm seeing now from minus.
Log base 4 of 4x plus 1.
Let Joan zoom.
Yes, Arinda is telling you to
And
zoom.
actually for you, Alinda, you are sleeping.
I don't know about that, but she has said use zoom, so she should be awake. Okay, so it's log base minus log base 4 of 4x plus 1 is equal to 2. So, yeah, is equal to 2. There we go. Right, so let's try that so that I can now we can look at other examples. We combine that with what we looked at on Tuesday, and then the other the first day of logarithms. So I am going to give you quite a good some numbers for you to do after here, so you take note of them.
I'm getting 0.
You're getting 0.
X is
X is 0. Sure.
Let me try again, and let me try.
Okay, try again. I'm also trying here.
So for me, I've got negative 18 over 61 as x.
Yes, x should be negative 18 over 61.
61.
Yes?
Yes, sir.
Joan is now a pure mathematician.
I can see.
Oh, sleep.
That is true. Okay. Yes. We okay. Yes. So check it, test it. Does it give us the answer? You need to check it first, because it may not be correct. It may not give us the answer, so we would say this one has no solution. Yeah.
I know it will be hard for Joan to put a fraction and check using a fraction.
She's going to do today. Joanna, go ahead. Checking. Sharima, have you
So we are
checked?
still working on it.
I want to hear from Sharima
Yeah,
whether
we are
she
okay.
has
I'm
checked.
still working on it.
You had gotten
I'm
0.
checking.
You
I'm
had
checking.
gotten 0 earlier, huh? Where was the
I had
problem?
considered 2. No, I had considered 2 instead of considering log 4 power 2. Yeah.
Okay. Right. So you went check. I want to hear.
I'm waiting for John to challenge me today.
You're in trouble.
So for me, there is a certain step where I've stopped. I don't know how to proceed. Because I said that x d3 times negative 81 over 16 over 61. 3 times negative 18 over 61 minus 2. Now I said 3 times negative 3 times negative 18, and I got 54. Now again I said 61 times 2.
What
So
did
is
you
it
get?
the correct process?
Explain again.
I said that 3 times negative 18, and again I said 61 times negative 2. Now I got negative 54 over negative 122
Is it over?
as this first log.
Is it over?
Remember, over negative 122. I'm just calculating the first log of the left side.
Yes, it is over 64. The LCM is 61 rather. LCM is 61. Look
Yes,
at the LCM.
LCM is 61. Whereby I said that 3 times negative 18 over the LCM. And again I said the LCM, which is 61 times negative 2. Is it true?
That is correct, yes.
Yes, now
So proceed.
I got negative 54 over negative 122.
Not over. Negative
Yes,
54
over
and negative 122 are on the numerator side. They are up.
Yes. What I'm calculating is only a log of one side of the left side. Remember, we have two logs on the left side, and now I'm calculating the first log, which is 3x minus 2.
Yes. So that component must be negative 176 over 64. Negative 176 over 61 rather. That's the first component. Are you with me?
We are not saying that 3 times negative 18.
You are. You combine them. Negative is still negative, huh? You do.
Yes.
So what's your final?
Which is in negative.
Yes.
Pardon?
Yes, it is negative 54, which is correct. Then minus what?
Minus the second log. I've not yet calculated the second log. I was just confirming whether my process of the first log is true.
You are close, but you need to you have to finish that first one properly. Huh?
Now, so that's why I was asking to say that 61 times negative 2, is it the correct process?
61 times? Negative
61
2.
times negative 2 on this 3x.
Yes, it
minus
is correct.
2, the first log.
LCM, so it is correct, yes. Very correct.
Okay, sir.
So, you're on the right path. This is a number we did, only that I gave it to you in a different way, but it is the same number.
Sir, the next log I got 72 over 60 over 61.
70 what?
72 over 61, and I said that
plus
negative 54 over negative 122.
Then there is a 1.
Now
Where have you left? Where have you left the 1? You've forgotten the 1. 4x plus 1. Have you forgotten the 1?
I said 61 times 1. Is it correct?
Hey, 61.
Oh, it's supposed to be 61 plus 1.
Which plus again? John, why plus? Why plus 1 only?
This plus 1, I don't know. We add it, or we make it that 61 times that 1, or we make 61 plus that 1.
I think I see the challenge is still dealing with fractions. LCM is what? 61. There is still an LCM issue there. So
it's 61 times 1.
Yes. Which gives you what finally?
Yes, I will get 72 over 61, whereby down here
no. So where is this? You have left a 61. You are still leaving out the 61 times 1 is 61.
Yes, I got it that it's 61.
So when you combine with negative 72, what do you get?
I cross multiply. Now 61 goes up, 71 goes down.
Nope.
You remain with negative 11 over 61.
Yes, it's negative 11 over 61. That's the
Yes.
solution. You must add 61 to negative 72 because it is 4x plus 1. So when you put x, remember, is negative 18 over 61. So it's a fraction. So you must put everything under the same denominator. That is, you people still have that problem. It seems to be not going away. So it is negative 61 over negative 11 over 61, and then you put together now. So you are dividing two negative numbers, the result must be a positive. So Sharima, what do you end up with finally?
I'm still working on it.
Hey, I thought you had finished. So your final answer should be log base 4 of 176. Right, 176 over 11. So when you divide 176 by 11, what do you get? So it's correct, the solution is correct, x is correct, negative, but you needed to confirm it. You have to make sure that it is true. Okay, so you end up with if you worked it substituted correctly, you should get negative. You will be having now negative your log base 4, okay, log base 4 of negative 176 over 61 divided by negative 11 over 61. Okay, then you know that when you are dividing fractions, you multiply by the reciprocal of the other one. So you get the reciprocal. 11 over 61 is the same as 61 over 11, and both of them being negative, then it becomes positive. So 176 over 61 times 61 over 11, and you'll be ending up with log base 4 of 176 over 11. So that should be
16.
When you divide 176 by 11, what do you get? You get
16.
You get 16, and log base 4 of 16 is a 2, because that's the same as, what do you raise to power, what power do you raise 4 to get 16, and that is 2. So that should be is the correct answer to what we're given. So our x value is correct. So that proof is very important. Okay, now I would like you to pick, I'm sharing another one, right? So I would like you to,
Oh, excuse me, sir. I'm sorry. I'll join in later.
okay, so actually you may not join in again, because I am just giving you a few numbers to write, and then we end.
Okay, it's fine, sir. Maybe they will be patient.
They will give you we are signing out now, so I want you to, there are these numbers I would like you to write, very useful numbers. Okay, I want you to use number 3.
Yes, sir.
Write number 3. Okay, I want you to write number 3. Do number 3. We shall see the answers tomorrow. Now the whole of number 3, A, B, C, write them down or take a screenshot. This number 3, that, these 3 numbers. Okay, without using tables or without using calculators.
So it's a coursework.
Do those ones. I want to see them tomorrow.
To be marked, eh?
Yes.
Oh.
Okay, I've highlighted. Does highlighting look okay, or I remove the highlighting? This number 3 here. Number 3.
Sir, first remove.
I've removed. Okay, so there is number 3. A, B, C. Write them. Okay, are we all there?
Yes, sir.
Have you all finished getting the questions?
Yes.
Okay. Sharim, are you there? You finished? Okay, right, so I'm going to stop sharing now. Thank you for being here and thank you for joining. So I'm going to end this lecture here and we meet tomorrow at 7. Okay?
Okay, sir.
All right, have a good night then.
Good night too.
Okay.